Hello, and welcome to our mini lecture on gas solubility and colligative properties from our Chemistry 12 class. Gases can be dissolved into liquids. This is what carbonated beverages are. They are a solution of carbon dioxide gas and water with some flavorings. The solubility of a gas in a liquid is dependent on temperature and pressure. We will delve deeper into that later in this lecture. We will also discuss colligative properties. Colligative properties are physical properties of solutions which depend on the amount of solute present, not on the identity of the solute. The solubility of a gas in a solvent is directly proportional to the pressure of the gas. As you increase the vapor pressure of the gas, you will increase the amount of gas which dissolves into the solvent. The solubility is measured in moles per liter. The equation which allows you to calculate the solubility of a gas is called Henry's law. Henry's law states that the solubility, S, is equal to the Henry's constant for that gas, Kh, times the partial pressure of the gas. Each different gas has its own Henry's constant. Temperature affects solubility of dissolution of a solute into a solvent, but the physical state will determine how they are related. When you are dissolving a solid into a solvent and you increase temperature, you will increase the solubility of that solid. When you are dissolving a gas into a solvent and you increase temperature, you will decrease the solubility of the gas. A good example of the decrease in solubility of a gas in a hot solvent is the way that soda will go flat if you leave it out in the sun. The equation which allows you to relate two different vapor pressures at two different temperatures is the Clausius-Clapeyron equation. This equation will be given on all exams, including the final exam. You will be given all variables save one. You will use algebra to solve for the unknown variable. Colligative properties are properties of solutions that depend on how much solute is present, not on the solute's identity. Some important colligative properties are lowering of vapor pressure, raising boiling points, lowering freezing points, and osmosis. Molality is a measure of concentration similar to molarity. The difference is in the denominator. Molarity is moles of solute per liters of solution. Molality is moles of solute per kilogram of solvent. The abbreviation for molality is the lowercase letter m. A 1 molal solution of nickel 2 sulfate is exactly 1 mole of nickel 2 sulfate dissolved in 1 kilogram of water. Adding a solute to a solvent lowers the vapor pressure of the solvent. The new lower vapor pressure is calculated using the mole fraction of the solvent and the vapor pressure of the pure solvent. Remember that mole fraction is equal to the number of moles of a component divided by the total number of moles of the mixture. Adding a solute to a solvent will also change its boiling and freezing points. It will raise the boiling point, and it will lower the freezing point. The difference in the boiling and the freezing points, delta T, can be calculated from the molality, the freezing or boiling constant, and the Van't Hoff factor. Boiling and freezing points or constants are in tables in the appendix of your textbook. They are available online as well. The Van 't Hoff factor is the number of ions into which the solute dissociates. If the solute does not dissociate, then the Van 't Hoff factor is 1. The Van 't Hoff factor for sodium chloride is 2, because sodium chloride breaks up into 2 ions. The Van 't Hoff factor of magnesium nitrate is 3, because magnesium nitrate breaks up into 3 ions. Osmosis is the flow of a solvent, normally water, through a semi-permeable membrane into a more concentrated solution. When a concentrated solution is adjacent to pure water and they are separated by a semi-permeable membrane, the water passes through the membrane into the more concentrated solution to dilute it. The more concentrated the solution is, the more pressure is created that forces the water into the solution. If you measure the osmotic pressure and also know the volume of your concentrated solution, you can calculate the molar mass of the solute with a little algebra. This is called osmometry. This has been your mini lecture over solubility and colligative properties from our Chemistry 1412 course. Please go to Sapling at this time and complete any related assignments. If you need help, please do not hesitate to ask your instructor. Help is always available.